We have a sample problem here, a single acting, no? So we have a single acting air compressor that is operates at 150 rpm with an initial condition of air at 97.7 kPa and 27 degrees Celsius, and discharges the air at 397 kPa to a cylindrical tank, and the bore and the stroke are 355 mm and 381 mm respectively, with a percentage clearance of 5%. Now, if the surrounding air are at 100 kPa and 20 degrees Celsius, while the compression and expansion process are PB raised to 1.3, which is equal to C. Now determine A, the free air capacity in cubic meter per second, and B, the power of the compressor in kilowatt. So this is an ME board problem which is stated back in 1896. Right, so let's try to list down what are the given and the problem so that we can determine what will be the equation that we'll be using on this problem. So for our P1 dito, so we have that one which is initial pressure, so that will be 97, no? So we have a pressure of 97 kPa for our initial state. Then for our P2, so we have a discharge the air at 397, so that will be our P2, or pressure at point 2. Then for our T1, so we have that is 27 degrees Celsius. So I'm gonna add this one, dagdagan ko siya ng 273 to make it a Kelvin. So that is equal to 300 to make it Kelvin, so take note, so we have to make all calculations must be all absolute. Okay. For the pressure, so take note of this one also, yung 97.7 kPa, so it does not state the problem if it is absolute or call this gauge, eventually pag ang problem, there is a symbol sign which is merong sa given merong letter G na ganyan, so it means that yung pressure mo is in gauge pressure. So eventually sasabihin naman yan sa problem. But pag hindi in-state sa problem, if it is gauge, call this, hindi siya in-state na gauge pressure siya, so automatically you will be using the problem, automatically that is an absolute pressure. Now you will notice here also we don't have your T2, so can you check? So we have okay, we have 20 degrees, so 20 degrees, that is the surrounding air temperature, so that will be not our T2. So our T2 here is unknown, so the problem does not state kung anong temperature natin at the discharge stage or discharge point. Then we have also given here our bore and stroke, bore and stroke ng piston ng compressor. So for the bore, so that will be the diameter. Okay, so that will be the diameter, so that is 355 mm. Then we have your stroke, or that will be the length of stroke. So usually this is your letter L. So I'm gonna write here that will be 381 mm. So let's try to convert this one. So this one will be 0.355 meters. Para isang unit na lang tayo. So we can directly substitute this one to the equations. Then we have 0.381. So that will be your length of stroke ng compressor or ng piston. And we have also given to the problem, so we have your clearance dyan, no? So we have here your clearance, so that is 5%. So we have your clearance, which is 5%. So we have the surrounding, which is your 100 to and respect to 20 degrees Celsius, no? Outside. Okay, so let's try to draw the PV diagram so we can plot natin itong mga properties na ito so that we can easily identify, or we call this, we can also easily identify or visualize yung problem. Now what I have here, I draw here my coordinates. So I have my pressure dito. Then this is my volume. So we have your PV diagram. Now for your P1, so if you're going to plot that one in our pressure and volume coordinate, we have your P1, which is 97.1. So basically when we say 97.7, no? Sorry. So mababa siya. So if you're going to plot that one, so eventually talaga, which is dito, which is your 0. Okay, so 0 coordinates. So we have here your 97.7, okay, QPA. Then for our P2, so usually that is a higher pressure. So eventually it will fall doon sa taas. So that will be, so assumingly, no, so this is 397 kPa at this point, no, assumingly. So we don't have to put it in a graphing paper or graphing coordinates just to represent. This is ideally to represent, so how does our PV diagram will look like. Now I have drawn here the dotted line. So initially we have your point 1 starting at this point. So this is my point 1, so I'm gonna write that one as a point 1. Then I have here my point 2 at this part, and we have your flow of direction kung saan patakbo yung process natin. So compressing from point 1 going to your point 2. And we forgot to write here, we have your N, no? So our N for your RPM, so that is 150. So this is revolution per minute. Then I have my 0.3 dito. Then for my 0.4, so assumingly, no, since we don't have the data for this point, so assumingly we have your point here dito. Then I'm going to draw a line to connect this one. Now for our letter A, so for our letter A, which is yung hinahanap doon sa problem, so we need to find the pre-air capacity in cubic meter per second. Now, makikita nyo dito, we have completely drawn yung volume. So we have here volume values. So we have here volume 1 prime. So we have here your volume rate. So we have, this is your 0.4. Okay. So from here we have your volume displacement. So starting from 0.3, no, papunta to 1. So that will be volume displacement. Then I have here from your top dead center, so this is for your piston, that will be your B3, no? Then I have also the volume starting from top dead center going to your bottom dead center. So this will be your B1, no? So wag lang tayo malito, from your B1 to B1 prime. So B1 prime, usually this is the containment or yung volume of air which is being sucked. So that is yung volume of air that is mostly na napapakinabangan, no? Which is yung part ng this one, your clearance. So are just the clearance on your compressor. Now I have drawn here the piston. So we have here the section of reciprocating compressor to represent our PV diagram. Now during the suction stroke, no? So we have here the movement of piston that is going down, no? Pababa. Okay. Then during the suction stroke, so usually pasok ditong open ang intake valve, then pasok yung hangin dito, okay, during the suction stroke. So eventually and we have your discharge valve or discharge valve opening. Okay, so it is closed, no? So during the suction, so papasok ang hangin dito, so we have your intake, so air is flowing freely doon sa loob. So hindi siya totally napupuno. Okay, so there is a certain portion which is not filling up yung cylinder ng compressor, no? So there is a gap, no? So or free space, no? So we have here the portion which is yung tinatawag na, so which is called na top dead center, no? So we have here at this part. So the main purpose that we have your top dead center and you have your clearance here, in order na yung piston will not tatama doon sa mga opening valves or intake valve and discharge valve. So there will be a clearance, so depending on the percentage, no? Then we have din dito sa baba, which is the bottom dead center. Okay, so ito yon, bottom. We have here your bottom dead center, which is yung pinaka lower part that the piston can move pababa, no? So you have here the rotation of your crankshaft. So we have your crankshaft and you have your connecting rod ng compressor. Now, so the problem also state there. So we have your 100, no? 100, call this cu.m and 20 degrees surrounding. So if we're going to represent that one, so usually that is surrounding, which is outside ng compressor mo. So we have here surrounding, which is 100 kPa. Then I'm gonna name this one as my rename this one as my piece of O. Okay. Then I have, since it is outside, piece of O, which is your 20 degrees Celsius. Okay, so adding ng natin ng make it absolute. So this is equal 20 degrees plus 273. So we have this is 293 Kelvin for our temperature outside. Now we're looking for the free air capacity in cubic meter per second. Okay, so when you say free air, so that is or free outside doon sa sa compressor. So free air, which is this one, is we have here outside. We're looking for your piece of O, so which is the volume outside before siya pumasok doon. Okay? So, yun ang hinahanap natin sa letter A. So, we're looking for your free air, which is outside. When you say free, so usually circulating outside, which is eventually papasok doon sa ating compressor. Now, we can compute this one by using your relationship, no? So, we have your initial P sub O and B sub O. Then, this is be divided by T sub O. So, since this one from here outside, then papasok siya doon, we have a second state, no? So, this is first state, and we have your 0.1 for your second state. So, we can equate this one to P sub 1 and B sub 1 divided by your T sub 1, no? Okay, so since we have here your pressure already given, so meron yan, yung B1, or let's say this is your, papasok mo dito, this is your volume flow rate 1, so this is, sorry, that is the volume 1 prime, no? So we're looking for your volume 1 prime. So ito yung mostly the air na napapakinabangan ng compressor. So your volume 1 prime. So ito yung volume ng air na yan, which is being worked by o pinapakinabangan ng compressor to deliver, no? Since we don't have the value for this one, so wala pa tayong value, but we have the value for your T sub 1, so that is already given here, no? Then we have your TO and TO. Okay, so what we don't have is your volume flow rate 1 prime. So yun ang hanapin natin. Now we can compute our volume 1 prime, no? So we have your relationship. Okay, so we have your relationship or your volumetric efficiency, so that will be equal to your B1 volume flow rate 1 prime. So this is divided by your volume displaced, and we can further express this one. We can rewrite our equations since we're looking for your volume 1 prime. So we have your volume 1 prime, which is equal now to your volumetric efficiency times your volume displaced. Then ang volume displaced natin, no, your VD, which is expressed as your pi over 4. We have your bore, ang butas ng piston, the pi dn. So we have pi d squared, then multiplied by the length of stroke, and we have your n for your RPM. And we can further express this equation as your pi over 4. So we have your d squared, and we have your length of stroke times your n, and the number of your if it is double acting or single acting. Okay, so since the problem states that it is only a single acting, okay, so what I'm going to do is we're going to multiply by it by 1. So checking the equation natin dito, so we have already your diameter given sa problem, no? So we have 0.355, and checking your length, we have 0.381, so meron, and we have your RPM, so that is 150. So we can directly substitute it to the equation. So we have your BD, so that will be pi over 4 times the diameter, that will be 0.355. So that is the unit of meter. So I'm gonna raise this one to squared, then multiply this one by your length of stroke, so that will be 0.381 meter, no? Then we have your RPM, which is 150. So this is the unit of revolution per minute. Then I'm gonna convert this one directly to our seconds. I need to convert this one to seconds, so I'm going to multiply this one. We have your 1 minute, okay, and we have your conversion 60 seconds. So using our calculator, so we have the value for your BD is equal to, so I have here a value of 0.0, this is 943. So for the units, so cancel out your minute here, so we have here the unit of cubic meter per second. Okay, so examining yung equation natin for your P1 prime. So what we don't have, we have already the volume displaced, so this is okay. Then next with wala na lang tayo, which is yung volumetric efficiency. So remembering the equation for your volumetric efficiency is given by, we have your volumetric efficiency is given by your, so that will be 1 plus C, so that will be minus C, and we shall multiply this one by P sub 2 over P sub 1, so this is raised to 1 over your N. Okay, so we have the given already for your clearance, so given is a problem. Then we have the value of P2 and P1, and we have your N, which is equal to 1.3. So let's directly substitute that one to our equation of your volumetric efficiency. So that will be 1 plus yung value ng clearance, that will be 0.05, that will be minus 0.05, no? I'm gonna multiply this one, close parenthesis, we have your pressure 2, which is 397, so this is the unit of kPa, okay? Then divided by 97, 97.7, so the units of also kPa. Then we can call this close parenthesis of this one, and we can raise it to the power of your 1 divided by your N, which is 1.3. Okay, then we have the value of your volumetric efficiency, which is equal now to 0. That will be 9029. Okay. So now we have the value of your volumetric efficiency, so pwede na natin siyang i-substitute directly. So we have okay, so we have your equation for your volume flow rate 1 prime, so this is equal now to your volumetric efficiency, that will be point, so that is 9029. I'm gonna multiply this one by volume displaced, 0.0943, so this is the unit of cubic meter per second. So using your calculator, we have a volume 1 prime is equal to, so I have my volume that is equal to 0.085. okay, so the units is cubic meter per second. Now our equation here, so we can rewrite that equation to para makuha natin yung B sub O. So we have your B sub O, so that will be equal to your pressure 1, so we have your volume 1 prime, then divided by your T1, and we're going to transpose your TO and TO here, so we have your TO, then this is TO sa taas, so we're gonna multiply this one by TO, then this is divided by P sub O, so or we can say that this will become now your P sub 1 over your P sub O. Okay, then we have multiply it by T sub O and P sub 1. Okay, then this is multiplied by the volume flow rate prime 1. So, let's try to substitute yung values dito, no? Para makuha na natin yung sagot for your letter A. So, P1, we have that is 97. So, that is 97.7 kVA. Then, this is divided by your piece of bow, where your piece of bow, which is your 100 kPa. Then multiply this one by the ratio of piece of bow. We have here 293. Okay, so this is 293 Kelvin divided by your T sub 1, where T sub 1, which is 300 Kelvin. Then multiply it by your B1 prime, so which is the value of B1 prime we have here 0.085, so with the units of cubic meter per second. So finally we have the value of V sub O, or your volume of free air, and before entering the compressor. So this is 0.0, that will be 81. Okay, so we have cubic meter per second. So let's try to box yung answer na ito. So boxing this one, so we have your answer for letter A. So next, the power of the compressor, so in units of kilowatt. Okay. So this is direct substitution na lang, since we have already the properties dito. So we have your work, which is equal to your N, no? Then this is multiplied by your P sub 1, then volume flow rate 1 prime, okay? Then this is divided by your 1 minus your N. Then I'm gonna multiply this one by your ratio of P sub 2, P sub 1. Then this is raised to N minus 1 over N, then minus 1. Okay. So let's try to substitute directly yung mga values dito. So we have your N, which is equal to your 1.3. Oh, sorry, this is 1.3. It's 1.3. Then multiply this one by the value of P sub 1, which is 97.7. So I'm gonna express this one in thousands. So this is 97,700. So for the units of Newton per square meter, then it is divided by your 1, no, this is your 1. We have your 1 minus your N, or let's say this is value of your N 1.3. Then multiplying, we have here your values for your P sub 2, so that is 397. So I'm gonna express this one in kilo, since magka-cancel out naman sila sa baba. So no need to be caution on this one, since magka-cancel naman sila. Then this is divided by 397, divided by a piece of 1, since is 97.7 kPa. Okay, I'm gonna raise this one into the units of, how much is this one? That will be 1.3 minus 1, okay, all over divided by your 1.3, then minus 1, okay. So we have your work is equal to, so let's try to check ano bang kulang natin. Okay, so I forgot to enter here, since, so yun ang sinasabi ko from my previous lecture, that is if you're going to check yung units here, so may nakalimutan ako, no? I forgot to include yung V sub 1, okay? So since I check my units, no, so nakita ko na your work is Newton per square meter lang, so we're kulang pa tayo. So that's why very ano talaga yung malaking tulong when you are checking the units. So when you say work, so dapat supposed to be ang unit niya will be ano na siya kaagad, that will be Newton meter per second, no? And since here nawawala yung meter per second natin dito or second, so yun pala makikita nyo that the solution are erroneous and it will lead you to an erroneous answer. Okay, so I already inserted yung B1 prime natin dito, boiling flow rate. Now, again, checking yung units natin dito. So, eventually, we're going to cancel this one and we'll be canceling this one. Okay, so mapapansin nyo, we are now in the units of Newton meter per second. So, okay, so that is one way, no? To checking yung solutions are tinuturo ka on the right answer. So using my calculator, so I have the answer which is negative 13,747. That will be 0.45. So this is the units of watts, or let's say this is your negative 13.7 kilowatt. Okay, so let's try to box yung answer. So we have your final answer here, okay, for your letter B. Okay, so doon at the top, that ends my solution. Okay, so hope it will helps for you to fully understand the solving of compressors. Okay.